Hello, welcome to this lecture on the course on computer aided power system analysis. In the last lecture, we have talked about the basic principle of the LU decomposition. So, in this lecture, we would be looking into the detailed procedure of the LU decomposition followed by an example. So, let us start. So, what we have is we said that if we have got an matrix A, so we are talking about LU decomposition, let us say we have a matrix A 4 cross 4 matrix that we would like to lower triangular and an upper triangular matrix. Sorry. Then we have got so this is a standard lower triangular matrix, and then we have an upper triangular matrix where you would have then we will have 0, then beta, then 0 0, 0 0 0, beta 4 4. So, I have given a matrix, we would like to decompose this given matrix into this two lower and upper triangular matrix. Obviously, this is my L matrix, this is my U matrix. So, then here because we have taken the example of 4 cross 4 matrix. So, if it is 4 cross 4 matrix, so then therefore, total number of elements is 16. But then here how many elements we have got? I mean we have actually have to compute, here 1, 2, 3, 4, 5, 6, 10 plus 10, that is 20. So, then therefore, for an n cross n matrix, so for an n cross n matrix, we have to find rather n square plus n elements. So, this is pretty apparent from here because if you see we have already got this field, and then in this 6 we can put this 6, and then we are only remained with this and this. So, then therefore, this 10 plus this 6, 16 plus 1 2 3 4 20. So, essentially what is happening, that this extra n terms is coming because we have got in both these matrices L and U, we have got this elements at the main diagonal to be computed. So, now because I have got only 16 known quantities, 16 known quantities are coming from the 16 elements of this matrix A. So, essentially in general we have got actually n square known quantities, but then we have to compute n square plus n unknown quantities. So, then therefore, we have to pre-specify n quantities. So, usually we set alpha I is equal to 1 for I is equal to 1 to n. Usually we set alpha I is equal to 1 for I is equal to 1 to n. So, essentially what is meaning, that we simply set all these diagonal elements of the lower triangular matrix to be equal to 1, and once we set all the diagonal elements of the lower triangular matrix equal to 1. So, then therefore, after that we are only left with n square unknown quantities, and also we have got n square known quantities. So, then hopefully you would be able to solve this. Now, to solve this, instead of trying to solve this by any mathematical process, or rather by any kind of a closed form expression, what we usually follow is something called Kraut's algorithm. So, we now would simply like to look at that what this Kraut's algorithm is. So, this algorithm is a very beautiful algorithm and very easy to code. So, then for any n cross n matrix, if we simply apply this Kraut's algorithm, so then we would be able to find out the L and U matrix for a given A matrix. So, then now let us look at that what is Kraut's algorithm. So, in this Kraut's algorithm, so this is triangular factorization, we are here actually talking about this L U factorization. So, in this Kraut then in this Kraut's algorithm what we do in the first step. So, then essentially here, so in this algorithm essentially we are given this matrix A, which is already given. So, in the first step we set alpha I is equal to 1 for I is equal to 1, 2, 3 is equal to n. We have just now discussed the rationality behind them. Then for each j 1, 2, 3 is equal to n, perform the following operation. Now, here in this there is a little mistake. For I is equal to 1, 2, 3 to n, it should be actually j, it should be actually j, it is not n, it should be actually j. So, for I is equal to 1, 2, 3 j, solve for beta I j as by this expression, and then here note when I is equal to 1, this particular summation in the equation 3 point, I mean in this particular equation, in this equation. So, basically 3.52 is essentially this equation, in this equation is essentially taken to be 0, because you see in this case what will happen when I is equal to 1. So, then therefore, this particular index will go from k is equal to 1 to 0, going from k is equal to 1 to 0 does not have any meaning. So, then therefore, in that case this particular summation would be 0. So, then in that case essentially beta I j would be equal to A I j. Please note that this A I j are the elements of the matrix A. So, this A I j are the elements of this matrix J, and we are trying to solve for all alpha and beta. And after that, once we are done with this, then after that I is equal to j plus 1 to j plus 2 to n, we solve for alpha I j. So, then here first we are solving for this beta I j is nothing but the corresponding to this upper triangular matrix. So, this corresponds to upper triangular matrix. So, this is upper triangular matrix, and this corresponds to lower triangular matrix, So, after that what happens, that we simply keep on doing these two steps one by one till we reach j is equal to 1, 2, 3 to n. Now, from this particular algorithm nothing is really very much clear. So, then let us look at an example to understand this algorithm in much more detail. So, let us take an example. So, now just for the sake of convenience, we have taken an matrix A, which is basically 3 cross 3 matrix. So, this is the matrix 3, 2, 7, 2, 3, 1, 3, 4, 1, and we would like to decompose this matrix A into a matrix L and into a matrix U. So, this is nothing but matrix L and this is the nothing but matrix U. So, in the first step, as we have said that we would first alpha I is equal to 1 for I is equal to 1, 2, 3 n. So, here in this case n is equal to 3. So, in this case a n is equal to 3. So, then therefore, in the first case we simply set alpha 1 1 is equal to 1, alpha 2 2 is equal to 1, alpha 3 3 is equal to 1. So, by this algorithm alpha 1 1 is equal to 1, 2 3 1 is 1. So, now here for each j is equal to 1 2 3 to n. So, then therefore, j will vary from 1 2 and 3. So, for each j 1, for each j 2, for each j is equal to 3, we have to follow these two steps, first this step and secondly this step. So, when j is equal to 1, so what we will do? So, now here j is equal to 1, so then I will now actually vary from 1 2 3 to j, and now so then therefore, j is equal to 1. So, then therefore, when j is equal to 1, I will only have one value, that is 1. So, then therefore, it will be beta 1 1, I is equal to 1, j is equal to 1. So, it would be beta 1 1, that would be equal to a 1 1 minus, now because I is equal to 1 and we have just now said that when I is equal to 1 this term is equal to 0. So, then therefore, beta 1 1 would be equal to a 1 1. So, this is exactly the case. So, beta 1 1 would be is equal to a 1 1. So, this is a 1 1 and that is nothing but is equal to 3. So, this is a 1 1, this is equal to 3. Now, so after we are finished with this, now from here I will vary from j plus 1 to j plus 2 to n. So, then therefore, because n is equal to 3 and here j is equal to 1. So, then therefore, I will now take two values, I will now take values of 2 and 3. So, in this step I will now take values from 2 and 3. So, the first case, so it would be alpha 2 I is equal to 2 in the, so when first I is equal to 2. So, it is alpha 2 I 1, I mean here I is equal to 2 and j is equal to 1. So, alpha 2 1 would be equal to 1 by beta 1 1, please note that here in this case j is equal to 1. So, it is 1 by beta 1 1, we have just now computed beta 1 1 from here. It would be equal to a 2 1, it would be equal to a 2 1 because I is equal to 2 and j is equal to 1, a 2 1 minus, now here j is equal to 1. So, then here also this index k will vary from 1 to 0, which does not have any meaning. So, then therefore, this particular summation would be equal to 0. So, then therefore, alpha to 1 would be equal to 1 by beta 1 1 into a to 1. So, it would be, so basically that is what it is, alpha to 1 is equal to 1 by beta 1 1 into a to 1, beta 1 1 is equal to 3, you have just now calculated, a to 1 is 2. So, it is 2 by 3. Come here, so after this I now will take a value of 3. So, when I will now take a value of 3, so then therefore, this would be alpha 3 1 because I is equal to 3 and j is equal to 1. So, alpha 3 1 that is would be equal to 1 by beta 1 1 because j is still 1 into a is nothing but the element of the given matrix A, this is a 3 1 minus, now here still j is equal to 1. So, then therefore, this summation does not have any meaning because this index will go from 1 to 0. So, this summation does not have any meaning. So, then it would be 1 by beta 1 1 into a 3 1. So, that is what precisely it is. So, alpha 3 1 would be equal to 1 by beta 1 1 into a 3 1 and a 3 1 is 3 and beta 1 1 is 3. So, then it is equal to 1. So, then when we finish j is equal to 1, we have computed this quantity beta 1 1 and then after that we have computed a 2 1 and a 3 1. Please note that alpha 1 1, alpha 2 2 and alpha 3 3 they are already calculated from here, and in the first step we have calculated this and this and this. After this, so now, so then we have finished the computation for j is equal to 1. So, when we have finished this computation for j is equal to 1, after that j will take a value of 2. Now, when j will take a value of 2, now I will vary from 1 to 2 because I will vary from 1 to 3 to 2. So, then I will take now 2 values 1 and 2. So, now, so in the first case what will have I is equal to 1 and j is equal to 2. So, what we will have here beta 1 2, because I is equal to 1 and j is equal to 2. So, it is beta 1 2 is equal to a 1 2 minus, because I is equal to 1. So, then therefore, again this particular summation does not have any meaning. So, then therefore, beta 1 2 would be equal to a 1 2. So, when j is equal to 2, so beta 1 2 would be equal to a 1 2, and a 1 2, if we look at this, a 1 2 is 2. So, then therefore, beta 1 2 is equal to a 1 2, that is equal to 2. Fine. After this, what happens? Now, here j will here I will take a value of 2. Please note that when j is equal to 1, we will first finish this part, then we will finish this part, right. So, when j is equal to 2, I will have to take two values 1 and 2. So, now here I is first we have considered when I is taking a value of 1. So, now we have to consider the case when I is taking a value of 2. So, now when I is equal to 2 and j is equal to 2, what we have got beta 2 2 is equal to a 2 2. Please note here I is equal to 2 and j is equal to 2. So, beta 2 2 is equal to a 2 2 minus, now I is equal to 2. So, then therefore, this index would vary from k is equal to 1 to 1. So, then therefore, this index will k will have only one value, that is k. So, it will be equal to alpha 2 1 into beta 1 2. Please note here in this case I is equal to 2, j is equal to 2. So, then therefore, a 2 2 minus alpha 2 1 into beta 1 2. So, let us see. So, beta 2 2 would be equal to a 2 2 minus alpha 2 1 into beta 1 2, and we have already computed beta 1 2 here, a 2 2 is already known, and alpha 2 1 we have calculated in the last step. So, if we put them, alpha 2 1 is equal to 2 by 3 and beta 1 2 is equal to 2 and a 2 2 is 3. So, if we put all these things, then we get it is 5 by 3, right. So, it would be 5 by 3. So, a 2 2 is 3 and it is 2. So, it is 5 by 3. So, 3 minus 4 by 3. So, it is 5 by 3. So, now when I has taken now the values of 1 to 2. Now, we come to this step. So, when we come to this step, I is now would be taking a value from j plus 1 to n. Now, n is 3 and j is equal to 2. So, then I will vary from 3 to 3. So, then or in other words, I will only have one value, that is 3. So, when I will have only one value, that is equal to 3. So, then in that case what will happen is, so now we will have alpha 3 2. Please note that alpha is equal, sorry, I is equal to 3, here I is equal to 3 and j is equal to 2. So, alpha 3 2 would be equal to 1 by beta 2 2. Please note that we are talking about here j is equal to 2. So, it would be 1 by beta 2 2 into a 3 2, I is equal to 3 and j is equal to 2 into a 3 2 minus, now j varies, now j is equal to 2. Now, because j is equal to 2, so then therefore, k will now vary from here 1 to 1, j minus 1 is 1. So, k would be varying from 1 to 1. So, it would be alpha 3 1 into beta 1 2. So, here what will happen ultimately finally. So, then what is the expression? Alpha I is equal to 3. So, I is equal to 3, j is equal to 2. So, alpha 3 2 is equal to 1 by beta 2 2 into a 3 2 minus alpha 3 1 into beta 1 2. So, this is what, let us see. So, alpha 3 2 is equal to 1 by beta 2 2 into a 3 2 minus alpha 3 1 into beta 1 2. Beta 2 2 we have just now calculated, a 3 2 is known, alpha 3 1 is known from here and beta 1 2 is known from here. So, all these values are known. So, we substitute all these values and we get a value of numerical value of 6/5. So, now because n is equal to 3, so now j takes a value of 3. So, when j takes a value of 3, so I varies from 1, 2 and 3, right. Now, first we have calculated this, then this, then this. In the second step, we have calculated beta 1 1 this, then alpha 2 1 this, then alpha 3 1 this. Then when j is equal to 2, we calculate beta 1 2 and beta 2 2. So, we calculate beta 1 2 and beta 2 2, and also we calculate alpha 3 2, we also calculate alpha 3 2. So, L matrix is already done. So, we have to now calculate this column. So, if we look at this, we actually here in this case we actually going from column wise. So, first in the case of L matrix, first we make all these diagonal elements is equal to 1, and then after we calculate the first element for the beta matrix for the U matrix, then we compute the first column elements. Then in the next step, when j is equal to 2, we solve for this column, and once we solve for this column, then we solve for the remaining element in the second column, right. And so, then therefore, when j is when j is would be equal to 3, so then therefore, we will now only solve for this column. So, essentially it goes by column wise. So, first, so when we start, we simply start this, we simply set this all these elements of this L matrix to be equal to one unity. Then we start with the first column of the U matrix, then we come back to the elements of the first column of the L matrix, that is basically when j is equal to 1. First we compute the elements of the first column of the U matrix, then we compute the elements of the first column of the L matrix which have not been computed. When j is equal to 2, first we compute the elements of the second column of the U matrix, and then we calculate the uncalculated elements of the second column of the L matrix. So, when j is equal to would be 3, we will calculate the elements of the third column of the U matrix, and then here we will come back again to the third column of the L matrix, but in the third column of the L matrix which is already known. So, there is nothing to be calculated. So, then by this we can easily simply so I mean this is basically the case of visualization of the entire process. So, first let us compute this calculation, then we will try to make it more general. So, let us go back what we are discussing. So, when j is equal to 3, so then I would be taking the values of 1, 2 and 3. So, when I is equal to 1, so it would be beta 1 3, that would be equal to a 1 3 minus I is equal to 1. So, then therefore, this particular summation does not have any meaning. So, then therefore, beta 1 3 would be equal to a 1 3. So, let us look at. So, beta 1 3 is equal to a 1 3, that is equal to 7. So, a 1 3 is equal to 7, that is equal to 7. Then I takes a value of 2. So, it would be beta 2 3 equal to a 2 3 minus, now I is equal to 2. So, then therefore, k will now have a value of 1 only, so because k would be only varying from 1 to 1. So, then therefore, what we will do that so then what we will have here alpha 2 1 into beta 1 3. So, it would be so then what would be the entire expression? Beta 2 3 is equal to a 2 3 minus alpha 2 1 into beta 1 3. So, this is what exactly is beta 2 3 is equal to a 2 3 minus alpha 2 1 into beta 1 3. So, here we have already solved for everything, alpha a to 3 is known, alpha to 1 we have just now calculated, alpha to 1 we have calculated in the first step. So, alpha to 1 is calculated, beta 1 we have just now calculated. So, if we just put this, we get this value. And in the last case, when I is equal to 3, so it would be beta 33 is equal to a 33. Now, k would now have two values 1 and 2, because I is equal to 3. So, this is 3 minus 1 is 2. So, now k would now take two values 1 and 2. So, it would be a 33 minus alpha 31 into beta 13 minus alpha 32 into beta 23. So, then it would be a 33 minus alpha 31 into beta 13 minus alpha 32 into beta 23. Now, here alpha 31 we have already solved, alpha 31 we have already solved from here, beta 13 we have solved from here, alpha 32 we have solved from here, beta 23 we have solved from here. So, we get this. So, all the elements are calculated. So, then therefore, then this is basically the result. So, this is the U matrix, this is the L matrix, this is the U matrix. So, then therefore, if we do this generalization. So, how do I now basically visualize this process? Let us say that I do have, just for the sake of example, let us say that I am taking a 5 cross 5 just for a sake of example. So, if we have a 5 cross 5, so how would it would go? Alpha 41, 42, 43, 440, alpha 51, alpha 52, 53, 54, 55. So, this is the L matrix we have to compute and multiplied by this beta matrix. So, it is beta 1 1. To 5, sorry, beta 2 2. Then beta, sorry, it would be 0 0 0 beta 4 4 beta 4 5, it would be 0 0 0 0 beta 5 5. So, this is the U matrix. So, now by the Krauts algorithm, how would you do? We will first set this all this alpha 1, alpha 2 2, alpha 3 3, alpha 4 4, alpha 5 5 to be equal to 1. So, we will first set this to be equal to 1. Then what we will do? Then we will take j is equal to 1. So, when we will take j is equal to 1, we will first compute this one. Once we compute this one, then in the second step of this Krauts algorithm, that is for j is equal to 1, please note that for each and every value of j, there are actually two steps. So, in the first step of corresponding to j is equal to 1, we first calculate this value, and in the second step we calculate these values. Then when j is equal to 2, so in the first step we calculate these values, and then in the second step corresponding to j is equal to 2, we calculate these values. When j is equal to 3, in the first step of corresponding to j is equal to 3, we calculate this column, because these are all 0. So, they do not have to be calculated, and we calculate these values. So, we are only calculated. So, we are basically moving column to column, first the column of this U matrix followed by the column of the L matrix, then again column of the U matrix followed by the column of the L matrix, then again column of the U matrix followed by the column of the L matrix. Similarly, for j is equal to 4, we calculate these values and then calculate these values, and for corresponding j is equal to 5, we calculate this column and then, and this is already calculated. So, we move from basically column wise. So, first this column, then this, then this, then this, then this, then this. So, we can see that this is a very elegant algorithm and it has got a very simple pattern, and if we, and when you have looked into this algorithm, it is very easy to code. So, then by this, given any matrix A, so we can, by applying Kraut's algorithm, we can simply decompose them into L and U, and then we have seen that how to calculate the final solution utilizing this L and U matrices. So, in this process of triangular factorization, we really do not have to do any explicit inverse of the matrix A. So, by this we finish our discussion on the numerical methods for solving a set of linear equations. From the next lecture onwards, we will start looking at some other aspects. Thank you.